We got geometry 7.3. We're looking at, gosh, what are we talking about? We're talking about angle-angle similarity, side-side-side similarity, and side-angle-side similarity. We've already done the first two. So really, the one that's new is side-angle-side similarity, and we'll talk about that. But right when we started doing with 7.1, day 1, day 2, I started talking about angle-angle similarity with triangles because third angle theorem exists, and once we know two angles of one triangle are congruent to two angles of the other, that third angle is already there. So we don't have to say anything more but talk about two angles of a triangle being congruent in order to use angle-angle similarity. And that's all it is. I've got two angles, and therefore the two triangles are similar. Now this only works with triangles. Okay, so keep that in mind. And today's objective is to use angle-angle similarity postulate, side-angle-side, and side-side-side theorems, for similarity, and to use similarity to find indirection with indirection of measurement, indirect measurements, I should say, not indirection. Our next one. Hey, let's check this out. We got practice of angle-angle similarity. And I use angle-angle similarity when they are similar and when they aren't similar to explain myself, okay? Because people are like, how do you know? And it's like, well, by this property. So are the two triangles similar? How do you know? Well, the first thing is it's in that bow tie configuration. From first semester, I remember that that's vertical angles. Okay, so right now I know two angles in one triangle are congruent to two angles in the other. And because of this property we just learned, I can talk about these two triangles being similar. Now, they don't ask me to write a statement of similarity, which would relate the two triangles together, but with corresponding angles. And I'm not going to worry about that because they don't ask me to. But that's how I use it. Once I know two angles are congruent to two others in the other triangle, I can use angle-angle similarity, okay? I do not need anything about sides. B, go ahead, look at that, see what you know. And remember, stuff from the first semester comes in like triangle sum theorem. All three angles of a triangle add up to 180 degrees, okay? All my markings will come in. Parallel lines will come in, so I'll be thinking about alternate interior, alternate exterior, corresponding. And as you saw in 1A, vertical angles as well. So now I've got 30 and 70, so K must be 80, and then P must be 25 if I do my, triangle sum theorem. And right now, what do I know about these two triangles and their angles? Yeah, they're not similar because the angles, I don't have the angles being the same. So now, I got some people that will write, well, you see, none of the angles are the same. All we have to do is say, hey, there's a similarity theorem, angle-angle similarity, that requires us to have two angles of one triangle congruent to two angles of the other. Because these two triangles do not have two angles, therefore three angles similar, congruent, the triangles cannot be similar for that reason, angle-angle similarity reason. So it's not about me showing or proving that the angles are the same and saying that they're similar all the time. I can use it to say they're not similar, and that's why I know that. Okay, it's a fact. Okay, if they are to be similar with angles, I have to have two of them by angle-angle similarity. Now, after we do this, why don't we look at 2A on your own, see how you do, okay, and think about that in application of angle-angle similarity. Are you okay that those two missing angles were 51 and 39? Pretty sweet that, hey, it works out. So I've got all three angles, and I got it done. Angle-angle similarity. Okay, now your turn. B, go for it. So because these are isosceles triangles, okay, base angles are congruent. So this is 68. And those 68ths, that's 136. That gives me a 44, or yeah, a 44 degree angle up there. Right now, I know because that other triangle has a vertex angle of 62, these two triangles can't be similar, okay, because the angles are different already. So because of angle-angle similarity, I know they're not similar. Does that make sense? So angle-angle similarity, check, we got it done. Next two, side-side-side similarity, which we already did in 7.1 and 7.2, because remember when we came across the figures, we lined up corresponding sides. You know, we took big figure over little figure, or little figure over big figure, whatever we did, lined up the corresponding sides in order, okay, and compared their relationship in the extended proportion, okay? When they were the same, and when we reduced, we used that extended proportion answer that each one of them had as the scale factor. Well, we're doing the same thing. Now we're just saying, hey, by the way, that's called side-side-side similarity today, okay? So that's our extension. Here, that's side-side-side. Our new one is side-angle side, which means if I have two angles, two separate triangles, congruent, and the sides that make those two angles are proportional, okay? I set up a proportion, you know, one side to the other side of each triangle, one triangle to the other side, corresponding sides. If those are proportional, then the two triangles are similar. And I only need two sets of sides, okay? Two pairs of sides and an angle, okay, in each triangle. So remember, the reds are about the reds. The blues are about the blues. When I set that up, so those, and the angles are there, the angles are included between the two triangles that we're doing, okay. So just remember that those are the two things we're going to do next, okay. Questions about these so far? If I'm going to use side angle side similarity, angles have to be congruent and the sides are proportional. If I'm going to use side 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 similarity, all the sides are proportional. So in 3A, I've got three sides, right? I don't have any angles. I'm going right for the side-side-side comparison. We did this in 7.1 and 7.2. I just had you write the lengths of the sides in order, whether it be greatest the smallest or smallest the greatest. I didn't care. So we did that. And we found that they reduced to the same value. They're all 2/3. Well, in 7.1 and 7.2 it was enough to say, okay, they're the same. So therefore, since the extended proportion is the same, we can say that the shapes are similar. Now we can just say that triangle STU is similar to triangle XVW because of side-side-side similarity. And I don't have to be wordy about it. Now, an example of the other one. And notice I have overlapping triangles. Matter of fact, I was so concerned with your understanding of overlapping triangles, I pulled them apart. Okay, because we have this triangle and we have this triangle. And in the problem, they're overlapping each other, just like that, okay? But in order for us to see it, I want you to notice that I'm just kind of pulling them apart. So I got corresponding sides. The two sides make the angle, so I have them in there. But I got 8 to 10, that's 8 plus 2 is 10. I know it's still 10. Crazy, right? 12 plus 3 is 15, so it's 12 to 15. And that's where I'm getting my 12 to 15, my 8 to 10. That's how I'm doing my setup. Corresponding sides around the two angles that are congruent in the separate triangles. So that's what I'm looking at if I set that up. Okay, so I've got my sides and they have the same proportion. And my angle is the same because angle K is the same in both triangles. That's that overlapping area, okay? So they are similar. And I want to make sure you recognize it's similar by side angle side similarity, okay? Now look those two over as you're writing them down, and it's now your turn. You guys are doing problem 4. You guys have problem 4 to get done. Okay, so hopefully we're noticed that this first one, we got side, 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 right? Because I didn't give you anything, any information about angles. So we're just going for that. We make that line up, and they end up being the same. I lucked out, right? And the next one, I have that overlapping triangle thing going on again, okay? And just to help out, I got the blue, I got a green, pulling them apart. Remember, in that green, I had 6 and 8. In the blue, I have 12 and 16. And that's how I can set that up, and they're a half with that relationship. 8 to 16, 6 to 12, the same angles involved. Okay, I want to emphasize this. This is side, angle, side. Okay, and I just have that overlapping triangle thing. I separated the triangles out. Okay, same picture, just so you can see what's going on with that. That's why that's 16, and that's why that's 12 as I go out here. Okay, now I have a conclusion. Remember, A is the same angle in both of those. So yes, they're similar triangles. And I've got triangle WAL similar to triangle EAC, because of side angle side similarity. Are we doing okay? All right, now, one of the things I want to point out today, I didn't start out class this way. I want you guys to read this t-shirt. There are 3 hikers, one kind of off in the distance, and then there's another one between the first and the last, and there's the hiker that's the last closest to the bear. Okay. Now, in this t-shirt, it says, coming in second never felt so good. I want you to think about that for a second. And some people are like, what's so funny about the t-shirt? And I will explain it this way. When you go out hiking in the backcountry, it's always good to be faster than one of the people you are with. Okay, does that make sense? Yeah, because you be barefoot. Okay, all right? But at least give that person, a fighting chance, bring along a little bat. Okay, anyways, so I saw this t-shirt in Alaska and I thought it was hilarious. Okay, and apparently Humphrey thinks it's pretty hilarious too. Humphrey, are you thinking about people you want to bring hiking with you that you know you can beat in a foot race? Okay, all right, so now we're looking at this and knowing that we're going to go hiking, class hike on a hiking trip. All right, and by the way, you guys are all safe. I can't run anymore. Okay, I wish I could. All right, so we're looking at this, and I want you to think that we're bringing along a mirror. And I'm going to put the mirror down on the ground. And the reason I'm doing the mirror is I'm going to use indirect measurement. Indirect measurement is a situation where I can't climb something or measure something because I don't have an apparatus with me, or I don't have a tape long enough to measure a height of something. And on top of that, I've got to be on top of it to measure it. Maybe I can use my GPS and elevation on my phone, but I always find out when I get out in the middle of nowhere, there aren't any cell towers, so I have no signal. How dare they not build a cell tower right in the middle of nowhere? Okay, I'm sure there's some sort of monetary need for them to build them and not build them. They make choices based on money, but for my convenience, I wish they'd just build them. Okay, but if I'm not going to have my phone working, if I don't have a satellite phone along, I'm going to measure the height that I'm going to climb. Say I want to climb that cliff just because it's there. Okay, I've got 100 feet of rope along in my backpack. I'm going to put this mirror down so I can estimate the height of my cliff because, we want to climb safely. We don't want to have someone fall, get hurt, and then, have to drag them out, carry them out, or, whatever, because we don't have self-service. So we put the mirror down, and I make adjustments between the mirror and the top of the cliff so I can see the top of the cliff in the mirror. Okay, I know my height. And in this problem, my height's 5.5 feet. By the way, 0.5 feet, how many inches is that? What's half a foot? Are you okay with 6? Half a foot is half of 12 inches. I'm concerned about this because there's a lot of students out there in the world that don't know that 5 feet 6 inches. Wow, that was, I guess I could have picked a better color. let's pick a better color. Let's use red. 5 feet 6 inches is actually 5.5 feet. Okay, they always go, it's like it's 5.6. Please don't do that. Okay, it's 5 feet 6 inches is 5.5 feet, 5.5 feet. Now we're going back to feet. We're going to do everything feet on this problem. So I'm 5.5 feet. I'm looking down, but my height corresponds to the height of the cliff in this problem because we're using side angle side similarity. I've got a side, the vertical height away from the ground, okay, and I got the length along the ground to the mirror, okay, in the smaller triangle on the left. If I go over on the other side and I pace out the distance from the mirror to approximate the distance to the base of the cliff, okay, and maybe there's some rubble in the way and I have to like say, oh, you know, that's another 4 or 5 steps, okay, and roughly each step's 3 feet. So I've approximated the length from the mirror to the cliff, you know, straight up to be 34 feet, okay? So my 6 feet and 34 correspond, okay? They're corresponding sides. My height, 5.5, and X correspond. So keep in mind what I'm doing here. I'm using similar triangles, side angle, side similarity. My angle is 90 degrees. I want to know how high this cliff is. Okay, I've got my rope. I want to know if it's enough rope to tie around one of the people that are going to climb up, and we're going to tie it off. We got little a hammer and stuff to make sure it's safety in the rope. It's just in case they fall. Okay, so it catches them before they really get to the ground. All right, and I'm just going to belay them on so they're safer. So a part of the rope's got to go around me too, and I don't want to stand right underneath them. So the rope's got to have some slack so I can step away and be out from the cliff. So that's what I'm planning. I'm wondering if I got enough to kind of double up and take care of all those safety precautions. So I'm just going to check it out. Okay. Set my mirror. I've got these measurements and I set up my relationship. 5.5 to X, 6 is the 34. Okay. And then I solve this. So you go ahead and solve. Go ahead and grab that thing and get it going. It's a good thing, at least my calculator works in my phone now. I didn't need a cell tower to get my calculator to work, so I'm checking it out on my calculator. So I cross multiply and I get that going on. Are you okay with 6x equals 187? I'm dividing by 6. Right now, even if I'm estimating, I know it's okay, 6, it's at least 30. Okay, it's at least 30 feet, but I find out it's 31.2 feet with my calculator. I got 100 feet of rope in my bag, so I've totally got enough, okay, to make this work. And I'm feeling very confident to wrap it around somebody, let them climb up and, you know, put in little holds and graphs so they can be safer on that climb. Are there any questions about what I did? Questions about corresponding sides using side angle side for proportionality to find those missing lengths. Okay, on top of it, you did learn today that if you ever do go hiking in the backcountry, you should be able to beat at least one person you're with. Otherwise, you might be the person that they're bringing along for safety reasons. Okay, so know that. Okay, and if you're concerned about that, maybe perhaps joining the track team this spring wouldn't be such a bad deal. Just kind of hide that speed later so they know that, you know, so they don't know how fast you really are. Now, last thing, 6A, B, and C. We have a self-quiz. Check it out, see what you know, go for it. When you are done with the first one and working on the second one, please check with your row partners, see how well they're doing too, please. And compare your answers. If there is a discrepancy between your answers, discuss how you arrived at them. Now on the first one, I hope you noticed that you have angle-angle similarity. You just had the vertical angle here, and this one and this one. Once I subtracted, I found out that these were the same. This was 100. So it totally worked out by angle-angle similarity. And the second one, I lined up the sides according to their lengths. I went small to big, or I could go big to small, and found out that they were proportional. And I could even tell you what their scale factor is based on my relationships here. Okay, 4 to 6, 3 to 4.5, 2 to 3. If you decided to go 6 to 4, 4.5 to 3, and 3 to 2, you're fine. It's going to be this a scale factor that's the same. In this case, the scale factor is 2 to 3, or 3 to 2, depending on how you lined it up. But my two triangles are similar, ABC is similar to FED, because of side-side-side similarity. And, sorry, I'm just getting up today's corrections if I can find them. Oh, good Lord. There it is. Took forever. Okay, just have to bring those up because we're going to talk about those next. Okay, and my last one. I got a side angle side similarity, and I'm checking that angles are the same, so now I just check the proportionality of the two sides. And they happen to be the same as well. Okay, now, are there any questions about the application of those three ideas? Angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Are you doing okay? We're done with notes. You have your assignment in your possession. I want to make sure you recognize that we have quite a bit of time to complete it today. Okay, this is one of those lessons that are brought to you by the makers of Just Get It Done. Okay, it's a subsidiary of the Nike Corporation, those folks who brought you Just Do It. Okay, so you have enough time to just get it done and ask questions today. So make sure you're using your time wisely. Okay, now what I've got going on here is our corrections from our previous day. We should have, rumors were flying. You should have known that with your filling out your code, but I need to see the work. Okay, I need to see your factors. The factors aren't out there. So you need to make sure you're showing those. So are there any questions on page 1, the rumors were flying page, the boarding house problem? We doing okay with the boarding house? No problems? Because you have a formative quiz tomorrow right away. And after you finish the quiz, you're going to start a review. Okay? And then we're going to talk about that formative quiz on quadratic formula. It's like 4 questions, 5 questions on factoring. And then we're going to do the 7172 formative quizzes. And we're going to talk about your review. And we're getting ready for a quiz we're going to take on Friday. On Friday, I'm going to do your 5-1 notes. Okay? And 5-1 day 1 and day 2, I'm going to have them both housed online in a video. Between Friday class, which is really going to be realistic to finish both sides of that video, okay, and Monday's at home digital day, you'll complete the videos for 5 and the assignment for 5 day 1 and 2 over those 2-day periods, okay? And it should be a pretty realistic thing for those folks that are doing it at home. So just know that we're going to do the quiz. We're going to get that done, and we got a pep test that day as well. Okay, so we're pretty busy, but it's pretty realistic. If you use your time well, you'll be fine. Okay, now, any other questions on this? And the next one. We are checking a count, by the way. Count Dracula, we put a bunch of squares on them. We put them checkered boards, so we were checking a count. It's pretty lame, but the most popular questions I had yesterday were these three. Not so much 10, but 8 and 9. Any questions on those today? Are we doing okay? So if I repeat them, you're fine. You're totally ready for them things because they were softballs you hit out of the park. Okay, park being, I don't know, Grand Canyon. Okay. We're all right? Please put your name on top of that assignment. Make sure your name's on top and hand it forward. And thanks for your time, and those folks at home, good luck with everything. If you need, come on in on campus and ask questions.